Hello, I'm Kenton, the Tech Pro, and today we are going to be talking about binary search tree. Now, the tree data structure is a very important data structure in programming and in interviews you might encounter. Now, if we talk about tree data structure, we will be talking about binary tree most of the time. And what's a binary tree? A binary tree is a tree structure that has two children for every node. So you can have two children or maximum of two children. So basically you can have a binary tree with three children like this. So this does not work. And now binary search tree is a binary tree that has particular kind of property. So in case of binary tree, we have a requirement that all the nodes in the right of the tree must be greater than the root. And all the nodes in the left of the tree will be less than the root. So what it means is that if we are going to insert, assuming we have this tree to be 7, and we have this to be 4, and we have this to be 10. So let's say we want to insert 3. At this point, if we try to insert 3, we have to check, is it less than or greater than the root? And if it's less than the root, then it means we are going to go to the left of the tree. When we come to the next node, we also ask, is it greater than or less? And in this case, it's less than, and we are going to go to this way, to the left. In the same way, if we want to insert, for instance, we want to insert 5, we are going to come here, is it greater than or less than? In this case, if this is less than 7, so it means we go this direction. Is greater than or less than is greater than 4, and it means we are going to insert 5 at this place. Now, this is interesting thing about binary search tree, that we can actually traverse all the elements of this tree and get everything printed in ascending order or in sorted order. So now I want you to take note of the concept of tree traversal. Now in binary search tree, there are 3 ways you can traverse a binary tree. One is called in order, 2 is called pre-order, and then 3 we have post-order, right? So let's take a typical example to illustrate this traversal methods of a tree. So let's take, for instance, we have a tree, we have this to be the root, 2, and we have 4. So if we are going to do another traversal of this tree, it means that we are going to start from the left subtree, move to the root, and then move to the root, and then move to the right subtree. If we are going to do pre-order traversal, it means that we are going to start from the root, and then move to the left subtree, and then move to the right subtree. So in this case, we are starting from the root, move to the left subtree, and then move to the right subtree. So in this case, we are moving from here to this way. If we are doing post-order traversal, we are going to move to the root as the last item to be traversed. So we're going to move right, left, and root. Alright, enough of these stories and theories about binary search tree. Let's actually implement it. Now I'm going to start a new file. This is a linked list we've done before now. So I'm going to say new class. And I'm going to call it, let me just call it binary tree. Okay. Alright, so we have a new class created, binary tree. Okay, it's coming up. Oh. Okay, so it seems it just crashed. Let's see. So I'm reopening Eclipse. So the tree data structure is actually interesting and it's something you need to know. And now let me just try to demonstrate something for you. Now if you are given a series of numbers, let's say we have, let me actually use blue. Let's say we have 24, 20, 17, 39, 6, 25, 7, 16, and let's say 40. We are told to build a tree using this. How would you do it? So as we wait for my application to open, it's taking some time to open. Let's try to see how we can build up this tree. Now I'm going to change my pen and use a smaller pen because I have very little space. So in this case, let me try to build it somewhere here. Or let me take out, make some space. Okay, let's try to build it. So let's start with 20. The next one is 17, so it goes here, 17. The next one is 39, so it goes here, 39. The next one is 6, so it goes from 20 to 6, it goes to 6. The next one is 25, so it goes this way and this way, so it comes here this way, 25. The next one is 7, so it goes here, here, and here. It actually goes from 6 to 7. Then we have 16, which actually comes from to 6. So we have 7. So I'm sure you can complete it. So let me go ahead to start a binary search tree. I'm going to say new, and I'm going to choose a new class, and I'm going to call it binary search tree. All right. Sometimes I like using a short name, so let me call it BS binary search tree. It's okay. Binary search tree is okay. Okay. So finish. So hopefully it's not going to crash this time. All right. So we have it. So now the first thing we are going to have in this tree is it should have a node, the left and the right. Right. So let's start node left and node right. I actually could have written it in one line, but it's fine. So let's say we have this tree holds integer items. Okay, and the data it holds is called data. So at this point, I'm going to put in a constructor public node takes data. Okay, so and we are going to simply say this dot. Okay, so okay, it's raising up this dot data. This dot data equals data. All right. So this is we have node int data, public node int data. What? Okay. So it should actually be public binary search tree. So public binary search tree. So all right. So this is what it should be. All right. So now we have our tree created. Now let me quickly write a function or a method to insert an item into a binary search tree. So what we are going to do, I'm going to now explain to you line by line what an insertion into a binary search tree will do. So let's call it insert, public void insert, and then we give an int value, then we are going to first check, compare this value with the root or with the data in this particular binary search tree. So basically, we are saying that if we have value, we are going to check if value is less than whatever is here. If it's less than whatever is here, then it means that we are going to go this direction. And if it's not, we go in this direction. So let's see. We are going to say if value is less than or equal to data. Okay. So okay, so we're on track. The value is less than data. What we are going to now do is to move to the left subtree. But for us to move to the left subtree, we are going to check if the left subtree is null. So I'm going to check if the left subtree, there is something in the left subtree. If there is nothing there, then just place the item there. If there is something already there, then simply recursively call insert. So simply recursively call insert in the left cell subtree. So let me write it so that it becomes clear. So I'm going to check if left is null. So if this is the case, I'm simply going to say left dot left is equal to new node, and I'm going to give it a value. All right. All right. So what we have here is that we've just inserted the value in the left place when there is nothing there. Okay, so let's now check. In this case, if left is not equal to null, I'm going to just say else. In this case, left is not equal to null. There is something there. I'm simply going to call insert. I'm going to just hit left.insert, insert, and I'm going to use value. All right. So far so good. Insert, perfect. Okay. So what do we have here? Insert. So I'm going to save. Everything is fine. So at this point, I'm going to come out from here. So at this point, I'm going to say else. Now, what we are now trying to check is situation where the value is actually greater than data. So in that case, we are going to the right subtree. So I'm going to say if value, I'm going to say if right is equal to null, then I'll simply create a new node at that point. So I'm going to say right equals new node value. All right. So at this point, we are now going to test a situation where the right is not null. So at this point, I'm simply going to say right dot insert value. Okay. All right. So we have errors here. I'm going to explain to you what really is causing it. Now I'm using node here. Meanwhile, I should actually use binary search tree. So basically, we have BST to be the BST, and we have BST because these subtrees are BST. So actually, I shouldn't use nodes. I should actually use binary search tree. So I'm going to copy this, and I'm going to copy it. Let's copy, and I'm going to replace this, and I'm going to replace this as well. All right. So new binary search tree, not new nodes. So what I'm going to ask you to do is to try to use node instead of to use a binary search tree as the name of your class. So we've succeeded in creating this tree, and we have built an insert method. So what we are now going to do is to write another function. This time, this function is going to be check. Okay, let's say search for a key in the tree. And the next one is going to be delete an item from the tree. Okay, then the next one is going to be print ordered list of items. Alright, so I'm going to stop here. I hope this has been informative for you. So I would like to thank you for viewing. Also, remember to subscribe to my channel. In that way, you get notified when I make new lessons. So we now meet in the next class to now look at the code for searching for an item in a binary search tree.